Hello everyone. Previously we had discussed on the topic binary search on the rotated array algorithm, right? So today we'll be going with the ternary search algorithm, right? So let's get into the definition part first. So what does this one definition part say? Let's see. So see here, ternary search is an algorithm for finding the maximum or minimum maximum or minimum of a unimodal function, right? So again, ternary search is an algorithm for finding the maximum or minimum of a unimodal function. A unimodal function is nothing but a function that increases then decreases or vice versa. Maybe it first decreases then increases, maybe, right? And vice versa, right? By repeatedly dividing the search interval, into three parts. So it repeatedly compares two interior points and discards 1/3 of the interval until the extremum is isolated, right? So this is the main definition of it. Let's try to understand the same thing with the explanation, right? So how the algorithm works, and then let's try to implement the same thing in the form of code or algorithm, right? So this is fine. So here, see, let's see how and when to use it, right? So when to use, let's see when to use first. So we will be making use of the ternary search when we have a unimodal function on an interval, right? So when we have an this one unimodal function on the interval, single peak or the single valley, right? So it's common in optimization problems where the objective is unimodal, right? So this is fine. So what's the core idea here? So this is important. So this will be helpful to write the code basically. See here, we will pick the 2 points, right? So first one will be pick the 2 points. Suppose consider m1 and m2 that split left and right, L comma R, right? So we will pick 2 points m1 and m2 that split L and R into the 3 equal parts. So this one m1 equals L plus R minus 1 by 3, m2 equals R minus L by 3. So this is fine. So what we will do, we'll evaluate f of m1 and f of m2, right? So we'll evaluate f of m1 and f of m2. If f of m1 is less than f of m2, the maximum lies on m1 comma R. So this point is very important. So if f of m1 is less than f of m2, then the maximum lies in m1 comma R. Otherwise it lies on L comma m2. Simple. Otherwise it lies on L comma m2, nothing but the left basically. Here m1 comma right, this one. Otherwise if f of m1 is greater than f of m2, then it lies in the left comma m2 basically, right? So simple, right? So we will repeat until the interval is small enough, right? So we will repeat until the interval is small enough. So when to stop basically? So see here, for continuous functions use an epsilon or the fixed number of iterations. So this point is very important, just remember this one. For continuous functions we have to make use of the epsilon or fixed number of iterations, right? For discrete integer problems we have to adjust to the integer comparisons and end when the interval size is less than or equal to 2, then brute force, right? So this is fine, I believe. Next let's go with the complexity. So what will be the time complexity here? Big of logarithmic n, right? So logarithmic number of iterations, this one to the base 3 basically, right? So this is fine. Each iterations does 2 functions evaluations. Just remember this, each iterations does 2 function evaluations, right? So see here, let's go with the caveat. So this one, the function must be unimodal on the search interval. Also if it is not unimodal, then ternary search can fail. The function must be strictly unimodal on the search interval, right? So if it is not unimodal, then ternary search can fail. Just try to remember this part. This is very important as well, right? So now let's try to implement the same thing in the form of code, right? So this is fine. First let's do one thing, let's define the unimodal function that we want to maximize, right? So first let's go with function f of x equals this one minus negative of x minus 2 whole square plus 3, right? So this is the parabola peaking at x equals 2. Just remember this again, we'll be going with a function f of x equals minus negative, right? So minus x minus 2 whole square plus 3. This is nothing but the parabola peaking at x equals 2. So I can just write it on this way, def. So this one is f of x, this is fine, function. So again, as I have said, function, this one we have to return function f of x equals minus x minus 2 whole square, right? So this one exponentiation operator, right? So let's make use of the exponentiation operator plus this one 3, nothing but a parabola picking at x equals 2, right? So this is fine, I believe. Now let's do one thing. Let's go with the main function, nothing but the ternary search max. I'll just go with def here, ternary search. So I'll just go with max here. This is fine. So let me go with left, right. Also this one function and iterations. So this one, let me assign this one to 100. So this is fine, man. Within the ternary search max this one method, let's do one thing. Let's repeat the fixed number of items, nothing but stopping criterion, right? So let me go with the for loop here for I in range. So this one is iterations. This one we have already considered. This one within this one 100 I have considered, right? Iterations equals 100 within the parameters. So within this for loop, let me assign m1 to so this one we have discussed this one in the discussion, right? Explanation part, sorry. This one has to be r minus l. As we have considered this one, we have to go with the 3.2, right? So same goes with the m2 as well. Let's copy the same thing and make the necessary changes that we want. So here this one will be m2. Instead of l, let's go with the r here. Instead of r minus l, this remains same, r minus l itself. So this one has to be minus r minus this one. This is fine. Yep. This is nothing but the first interval point. So this one, line number 36, this is nothing but the first interval point. So this is 1/3 from the left. So this is nothing but the line number 37. This is the second interval point. This is 1/3 from the right, right? So I hope these two things are clear. Now what we discussed here, if function of m1, see this one, this part, if function of m1 is less than function of m2, then max is in the m1 comma right, this one, right? So this one, otherwise it lies in l comma m2, it left comma m2 basically. So that condition we have to write now. So that is the only thing that is left basically, right? So I'll just come here. If function of m1, this one is less than function of m2, let me go with function of m2, then what we'll do, let me assign this one l to m1. Also else let me assign r to m2. So let me delete this one, r to m2, and let me return something. We have to return this one, right? Left plus right by 2 basically, l plus r by 2. Let me go with 2.2. This is fine. Yeah. So see here, what we have done here, if function m1 is less than m2, then max is in the this one, what do we call, m1 comma right, right? Nothing but we are assigning left to m1. Else otherwise we have to discard the right third, meaning we have to assign the r to m2. This is fine. Finally we are returning the midpoint of the final small interval. That is the reason we are going with l plus r by 2, right? So this is fine. Now let's do one thing. Let's go with the example usage, right? So we are done with algorithm. This is it for the algo, right? So let's set the interval and then let's run the search, right? So first I'll just go with left, right. Let's assign the left to 0 and let's assign the right to 4 here. This is fine. Next step would be, I'll just go with the estimate here. Let me assign this one to ternary search max. So this one will be left comma right. This is also fine. F comma this one. Let me go with the iterations and let me assign this one to the 100. So this is fine. Let's go with a print. So this is fine. Let me go with ternary search estimate for x. This is also fine, man. So let me go with so we are going with a maximum, right? So I'll just give maximum here. This is fine. What did I give here? Maximum. This has to be maximum, right? So this is fine, man. Let me go with here estimate. This is also fine, man. Let's go with a print. So this one is fine. Function value at estimate. So this is fine. F of x. This is also fine. This is fine. Next, let me go with f of estimate. This is also fine, man. Finally, let's go with a final print statement. So this is actual maximum is at x equals 2.0. This is fine, comma f of x, this is fine, equals 3.0. This is also fine. So yep, so this is it for the example usage, right? So the output that we need to get here is ternary search has to estimate. We are going with a estimation for the x, right? So the ternary search estimate for x maximum would be 1 point something, we have to get 999 something, we have to get, right? So function value at the estimate f of x, what we have considered 3.0, right? So we have to get here this one 3.0, and the actual maximum is at the x equals 2.0 comma f of x is 3.0. so that's what we need to get here, this one, the same thing, right? So see, let's see the same thing. So I'll just come here, let me copy this one, right? Let me give Control J here, Python, let me run the code, Python file name dot py. So see here, ternary search estimation for this one, 1 point something, we are getting correct this one, right? 1.99. function value at the estimate f of x, we are getting 3.0, the same thing. See here, this one, function value at the estimate f of x, estimation we are getting 3.0, which is absolutely correct. And also the actual maximum is at the x 2.0. this one we have already given, this one within the string, this is fine, right? So yep, so again, let me tell you one thing. So ternary search estimate for x maximum value, what we have got here, this one basically, so this is the algorithm's estimated x that maximizes the function f of x, this one that maximizes the function f of x. Again, just listen to this, this is algorithm's estimated x that maximizes the f of x. It is very close to the true maximum, this one 2.0. see, it is very close to the true this one, what do we call, maximum 2.0. the tiny difference is due to the finite iterations and floating point arithmetic, right? So again, the tiny difference is due to the finite iterations and floating point arithmetic. So this is fine. Now the next part is function value at the estimate f of x 3.0, whatever we have got here. For the estimate we have got 3.0, right? So in the output, so this one basically, so we are evaluating f at the estimate that gives 3.0 here, right? Or the 3, which matches the true peak value. Basically this is matching the true peak value, nothing but 3.0, right? So floating point arithmetic yields an exact 3.0 in the particular evaluation. So this we are getting correct. The final one here, actual maximum at x equals 2.0 and f of x equals 3.0. This one, this is just the reference line, basically just to remind us of the true solution for this particular example, right? This is just used to confirm the correctness, basically, right? F of x we have to get 3.0 and x we have 2.0, right? So this one we are getting C. F of x we are getting 3.0, and the ternary search estimate for x, this one as 1.999 something, last ending at the 388, right? So this is fine. So we are getting the correct output. So we are getting the exact output here basically for this one x, this one maximum, right? So this is fine, I believe. So this is it for the ternary search, right? Simple, right? So we are done with the ternary search. So I'll just summarize whatever we have learned so far. So first thing here, ternary search finds extrema, right? Max or minimum of a unimodal function by just splitting the interval into 3 parts each iteration, right? So the ternary search, what it does, it finds the extrema of a unimodal function by splitting the interval into 3 parts each iteration, right? Each iteration needs 2 function evaluations and removes 1/3 of the interval, right? Runtime as logarithmic in the interval length. This one we have already discussed. Just keep this in mind. This is important. So we will be making use of the fixed iteration count or an epsilon to stop, right? So basically we make use of the fixed iteration count or the epsilon to stop. For the integer domains, handle final small interval by brute force. We can just go with a brute force, right? So what are the important things here? We have to ensure that the function is unimodal on the interval. This one I have stressed this one multiple times. Otherwise, ternary search can fail, or otherwise results are unreliable, right? So just keep this in mind. So we have to ensure that function is unimodal on the interval, right? Otherwise results are unreliable. So advantage, main advantage of the ternary search over the binary search is ternary search is tailored to optimization, right? So this is for the unimodal maxima or the minima, and the binary search is just for locating an index or the value under monotonic conditions. Just remember this one, this is very important. So you have to know when and how to use this one, ternary search over the binary search, right? So mostly we'll be making use of the binary search most of the times, I'm speaking, right, rather than the ternary search. So ternary search, it is tailored for the optimization. It is tailored to optimization, basically unimodal maxima or the minima I'm speaking of, right? And binary search is just for the locating an index or the value under monotonic conditions, right? Yeah, these two solve the different problems, basically. Just remember this one. You have to know how and when to use the ternary and binary search. So this is it for the ternary search, right? So we are done with the ternary search, basically, right? So next we'll be discussing on the topic, this one, exponential search, basically. That will be the last topic in the search algorithms. For now, this is it. Thanks for watching, guys.